Hi everyone, my name is Chong Hui Ping, matrix number 210448. Today I'm going to explain about dimensionless analysis. So have you ever wondered why we need to learn dimensional analysis in fluid mechanics? So actually it's very important. For example, it's used to verify an equation if it's in compliance with the principle of homogeneity of dimensions. Secondly, to convert from one system of units to another. The third one, to determine or derive a relationship between two physical characteristics. The fourth, to express one attribute in terms of another. And the last one is to derive a relationship between two quantities. So what is dimension? Dimension is a measure of a physical quantity, and that doesn't include numerical values. So there are 7 primary dimensions that I've listed out. The first, electric current. Second, amount of light. Third, amount of matter. Fourth, mass. Fifth, temperature. Sixth, length. And last one, time. So here are the example of the primary dimensions with their own symbol, SI units and English units. SI units stand for International System of Units. So move on, the next one is the secondary dimensions. So secondary dimension can be derived as combination of the 7 primary dimensions. For example, velocity. Velocity is the combination of length and time. What is unit? Unit is a means of assigning a numerical value to that quantity. Move on to the next. Each of the dimension have their own unit. For example, length, the unit will be centimeter. Time, second, temperature, Kelvin, mass, and kilogram. So the defined units are based on the modern MLT system. M stands for mass, L stands for length, T stands for time. So all other quantities can be expressed in terms of these 3 basic units. For example, cross-section area. So it's m power of 2. So m stands for meter, which is length. So the dimension will be L power of 2. Move on to the next one is law of dimensional homogeneity. Law of dimensional homogeneity is the dimension of each of the terms of a dimension equal on both sides should be the same. So in another word, the left-hand side should be same as right-hand side. For example, the total change in total energy of the system, delta E, is given by delta E equals to delta U plus delta kinetic energy plus delta potential energy. So all of these have the same unit, which is J, joule, or Nm, or kg m squared s squared. So meaning that all of these are equivalent. The next example is Bernoulli equation. So the left-hand side and the right-hand side has the same dimensions, so which I have stated out here. Furthermore, non-dimensionalization. Non-dimensionalization is the removal of unit from physical quantities by a suitable substitution of variable. In other words, or in a more simple way, we can say that it's a non-dimension or dimensionless. For example, here is the Reynolds number, Mach number, and Euler number. So all of these are dimensionless, meaning that they don't have any dimension. So Baking-Pi theorem, it's used to determine the number of dimensional groups required to describe a phenomena. So reduction equal to m equal to n minus r. M stands for the minimum number of dimensions to describe the variables. N is the dimensional variable and r is the dimensionless variable. So we have 3 methods to determine the pi. First, inspection. Second, exponent method. And third is step-by-step method. So here I'm going to explain about the exponent method. In order to do the exponent method, or known as method of repeating variables, there are 8 steps that we should do. The first one is list out all the variables that involve. Second, express each of the variables in terms of basic dimensions. Third, determine the required number of pi terms. The fourth, select a repeating variables where the number required is equal to the number of reference dimensions. Fifth, form a pi term by multiplying one of the non-repeating variables by the product of the repeating variables. 6. Repeat step 5. Step 7. Check all the resulting pi terms to make sure they are dimensionless. And the last step, express the final form as a relationship among the pi terms and think about what it means. So here is the example. Step 1, we have to list out all the variables involved in the problem. Move on to step 2, express each of the variables in terms of basic dimension. For example, diameter. Diameter, the unit is m and dimension is length L. Step 3, determine the required number of pi term, which equals to R equals to n minus m. N is the dimension variable and m is the dimensionless variable. So we will get 2. Step 4. Select a number of repeating variables where the number required is equal to the number of reference dimensions. For this example, there are 3. So all of the required reference dimension must be included within the group of repeating variables, and each repeating variable must be dimensionally independent of other. So the rule 3 is do not choose the depend variables. Move on to step 5. Combine the dv with one additional variables. It's either the L or the change in pressure in sequence to find 2 pi product. So we substitute the equation and we'll get MLT. And then we will use simultaneous equation to find the value of A, B, and C, and then we'll substitute back the value. Step 6. Repeat step 5. However, we'll use another term which is the L. So we'll repeat the step in step 5 and we'll find the value of A, B, and C, and at the end we'll find the second pi which is equal to L divided with D. Step 7. Check all the resulting pi terms. One good way to do this is to express the variables in terms of FLT if the basic dimensions MLT were used initially. Last but not least, the last step is to express the final form as a relationship among the pi term. So at the end, the function relationship that must exist for one pi term is pi equal to c. C is a constant. In other words, if only one pi term is involved, it must be equal to the constant. That's all from me. Thank you.